Hey guys, welcome back. Today we're going to talk about regular polygons. And regular polygons are a special type of polygon. It's a polygon that is both equilateral and equiangular. So it's equilateral. Equilateral means all sides are congruent. And it's also equiangular. And equiangular, that means all angles are congruent. So for a regular polygon, some of them have special names. That would be like an equilateral triangle. Every side is the same, every angle is the same. When you're dealing with a quadrilateral, there's a special shape where every side is the same and every angle is the same. We call it a square. So a square is a regular quadrilateral. And then you could have like a pentagon, where every side is the same, not drawn to scale here, and every angle is the same. If that's true, we call them regular polygons, as opposed to having like, let's say, a quadrilateral that looks like this. You have 4 sides, 4 vertices, 4 angles, but clearly the sides aren't all the same, the angles definitely aren't all the same, so it's just a non-regular polygon. We're going to talk about regular ones today, where everything is congruent. Sides are congruent, angles are congruent. And we're going to use a lot of the things that we did yesterday as well. So our first question, how we're going to apply this, it says, find the measure of an interior angle of a regular quadrilateral. So, keywords here, you see the word regular. When you see that word, again, that means all of your sides are congruent. But in this case, we're trying to find the measure of an interior angle, so angles are congruent. That's going to be really important for us. And we're dealing with a quadrilateral. So quadrilaterals, well, we should know, or if we don't know, we can follow in the formula, but quadrilaterals, the angles add up to 360. If we didn't know, we can go back to that equation from yesterday. S equals 180 times n minus 2. The sum of the interior angles is equal to 180 times the number of sides or angles, which in this case would be 4, minus 2. So it would be 180 times 2, which is 360. So we're going to add up to 360. Now, we also have to think, if it's a regular quadrilateral, we know we add up to 360. If there's 4 angles and we add up to 360, and the angles have to be congruent, well, we would do 360 divided by 4, because we have 4 angles, so they each have to be the same. We're going to divide it equally, and if you do that, you get 90. So one angle in a regular quadrilateral has a measurement of 90 degrees. And since there's 4 of them, well, 90 plus 90 plus 90 plus 90, that would give you 360, and they're all the same. So for this one, we should get 90 degrees. Our next regular polygon that we're going to work with is a regular hexagon. So find the measure of an interior angle of a regular hexagon. So, again, you see that word regular. 3, 4, 5, 6. Hexagons, well, they have 6 sides. And if it's a regular hexagon, I'm going to mark all the angles congruent. So we have 6 angles. We want to find the measurement of one, and we're told that it is regular. So for every regular polygon, you know the angles are congruent. But we need to figure out what they add up to first. So let's go back to that equation. Sum of the angles is 180 times n minus 2. So the sum of the angles is 180 times 6 minus 2. Sum of the angles should be 180 times 4. Sum of the angles should be 720. So all 6 of these angles should add up to be 720. But if we want to find one of them, well, we know they have to be the same. So we're going to take that 720. We're going to divide it by 6 because there's 6 angles. They all need to be the same. And when we do that, we should get 120. So when you add up 126 times, 120 plus 120 all the way around, you get 720. They're all equal to 120. So let's do 2 more of practicing with these, and then we'll let you do a little more practice today. So our next one says, find the measure of an interior angle of a regular heptagon. So if you want to try this one on your own, feel free to pause, give it a shot on your own. A heptagon, if we don't remember, has 7 sides, or angles or vertices. So a heptagon, well, we need to figure out what the sum of the angles are in a heptagon. Well, we would use that formula again. Sum of the angles is 180 times 7 minus 2. So the sum of the angles is 180 times 5. So the sum of the angles should be 900. So that means when we take all 7 angles in a heptagon, we're going to end up with a sum of 900. But since it was a regular heptagon, that means all the angles are congruent. So if there's a sum of 900 and there's 7 of them, well, we're going to have to do 900 divided by 7. And when you do this, you're going to see you don't get a really nice number. We'll round to the nearest tenth. So we'll have 128, and when we round, we get 0.6. So each angle will have a measurement, not exactly, but approximately 128.6 degrees. And that would be for a regular heptagon. All right, our last one will be an 18gon. So remember, if a polygon has a lot of sides, they don't always have special names. So an 18gon, well, that just signifies that we have 18 angles. So we're going to have 18 angles, and we are told that it is regular. So we can find the measure of one of those 18 angles. Well, let's use that formula that we know. S is equal to 180 times n minus 2. So S is equal to 180 times 18 minus 2. So 180 times 16 is what we're going to end up doing. Do your 18 minus 2. And 180 times 16, we should get the sum of the interior angles is 2,880. And now we need to figure out what one of those angles is. Well, we know they all measure the same, so we're going to divide this evenly amongst 18 of them. So 2,880, we divide that evenly amongst 18 of them, and we should get each one has a measurement of 160 degrees here. So that's what we can do with regular polygons. Again, it has to be regular for us to know all the angles and sides are the same, but if that is true, then we know everything is congruent. All the sides are congruent, all the angles are congruent, and that can be really useful in finding some missing measurements. Alright guys, have a nice day.